kind of questions that these tools can answer. They can't answer everything about the future. They can tell us something about what we can expect for 30-year time periods, and we picked these 30 time periods because these are climate experiments, so they shouldn't be used to try and get information about the weather on a specific day in the future, but rather climate as an average over 30-year time periods. They can tell us what the models say about the projections, if the models agree on the projections, how large the uncertainty is, and how the projections change if you had a high emissions future scenario, if the emissions increased by a lot, or if we did some planning and reduced the emissions with RCP 4.5. So here, I'm just going to show some of the tools that we have in the next 10 minutes. First one we have is the Future Time Series tool. This tool helps to answer the question of what we can expect for over the next century. And here we have a smoothed version of the average from the different models, which is the red line. This goes from 1950 to 2100. Here we're showing summertime maximum temperature over Roseburg, and we just see that for this location that we have an increase of the average maximum temperature for summertime from probably about 82 up to 90 degrees. That's just a change in those summertime temperatures. And then here it shows the range of the different 20 models in the shading. And this is for the RCP for 8.5 emissions. Another tool we have is the Future Climate Boxplots tool. This tool helps to answer what the individual models say about the projections. Do the models agree on the projections, and how large is the uncertainty? So here we can look at the length of the growing season for Oregon City, Oregon, which is a berry growing area. And we can see the season lengths for the historical time period here. The length of the growing season is like on average 250 days between the last spring freeze and the first fall freeze. That's how it's defined just for this. And then in the early, mid, and late part of the 21st century, we see each of these dots are the individual 20 different models. The blue line is the average, the multi-model mean, and then you can also see the extent. You've got the outliers here, and you've got the 5 to 95th percentile. And so you can just see just from a glance that the length of the growing season is expected to increase here if you just look at the blue lines. And how much by you can hover over in the tool to find out how much, what these different means are, to see how much they're expected to project to change by. But then you can also see that the uncertainty is increasing because the range of the models is increasing here by the width of the boxes or the height of the boxes. Another tool we have is the Climate Mapper tool, which we've already seen. This tool helps to answer the question of what the individual models say about the projections, because you can actually select the different models here. You can look at the multi-model mean, but you can also look at the individual 20 models and see how they differ spatially over Oregon. And here in what we're seeing is that there is a projection of 29.8 more days of very high fire danger for this location in Medford, Oregon. So this is for the, this doesn't look quite right, but I think, so anyway, I'll move on. So another tool that we have is the Future Streamflows tool, which shows monthly hydrographs of non-regulated streamflows. And these are streamflows under natural flows without dams. And here I'm showing the streamflow for the Rogue River at Lost Creek Lake in Oregon. The black line here is the monthly streamflow from October to September, where you can see that the streamflow here is peaking in May. And this is historically, that's where it's peaking each year. And then this is under the RCP 8.5 scenario. So the high emission scenario, and we have projections for the streamflow hydrograph for the early, mid, and late parts of the century. And what we see So for the early is the blue, and then the mid is the late is the orange, and the end is the pink. And what we see is that that peak is now not in May anymore. It is shifting to earlier in the year. And in fact, by the late part of the century, we actually see like two peaks here. One peak is happening in December and one in February. And those most likely correspond to how under warming conditions in the winter time, we're likely to have more of the precipitation falling as rain, not snow. And in the winter time, in February, that mountain snowpack that builds up is under warmer temperatures is likely to melt sooner. And so both those things is going to contribute to runoff, and it's going to go into the stream flow earlier in the year. And that's how these predictions are for the peaks to shift to earlier in the year and to actually have a two peak situation for the stream flow in Lost Creek. And there's another future modeling tool in the toolbox, which is the crop suitability tool. And it's for specialty crops like almonds, apples, blueberries, cherries, and grapes. And here I'm just showing a screen capture of it, highlighting Salem, Oregon. And what it's showing, and I picked Cabernet Sauvignon grapes, and what it's showing is the red is the locations of suitable growth of this type of grape, where you get suitability, climate suitability of that location for growing the grapes in at least 8 of every 10 years. And so you can kind of see the spatial extent of where you can grow grapes reliably by mid-century under the RCP 8.5 scenario. And by toggling between these different options, you can see how that changes on the map. And then when I select a location here in Salem, Oregon, you can see here that historically that's not suitable for growing Cabernet Sauvignon grapes in any years. So 0 out of 10 years is it suitable historically, but by mid-century, it bumps up to 7 out of 10 years. So Salem's going to be, it's projected to have good have a climate that's suitable for growing Cabernet Sauvignon grapes. And this tool actually breaks that climate suitability down into different areas that can affect the crop. So cold hardiness, heat accumulation, chill accumulation, frost damage, and to get an overall suitability.